Hello everybody, welcome back. In this video we are going to be creating some simple bands. First one we're going to do is a plain half round wedder. I'm going to go to Google. I'm just going to Google a finger size chart. And if I have a look here in Google Images, this is how you get your different finger sizes. So I'm going to click on one of these, just accept. And for this example, I want a size UK size L. So you can see that we've got a size L here, and I want a diameter millimeter. And this is giving us a diameter millimeter of 16.1. I can double check this against a different chart. Size L, this one's slightly different, 16.3. 16.1 is generally what I use for a size L. So I'm going to create a circle. I'm going to create it in the front viewport, starting at world origin, which is 0. Enter. And we want that to be 16.1. And I will just press enter. So that's our finger rail. Looking across at our box edit, you can see that we are 16.1 millimeters. Now I'm going to offset this. Offset. And offset on this on the outside. Now I want this to be finished at 1.8 millimeters thick. Now if I was to make this 1.8 millimeters, by the time it goes through the casting and cleaning process, this is actually going to be filed and polished back roughly about 0.015 millimeters. So whenever I do a shank, I like to add 0.15 millimeters to the thickness that I want. And this is going to allow for that cleaning up process. So in this case, it's 1.8 plus 0.15, which is 1.95 millimeters. Press enter, and I'm going to click on the outside here. And I can double check this by using our dimension, aligned dimension tool, clicking here and clicking here. You can see in the prompt there, I don't actually need to complete this command. It already shows that it's 1.95 millimeters thick. And that includes our 0.15 millimeter tolerance. So that is our inside and our outside finger rails. Let's now create a half round profile. For this, I'm going to use the arc tool. And this is it here. There's a few different ways of creating arcs. So I'm going to hit this little arrow here. And you can see that we've got starting from a center and drawing out like a radius. The second one is a start point, end point, and then a point on arc. I'm going to use this third one here, which is start, end, and direction. So I'll click on this, and it doesn't really matter where I select. Let's put that there. And I want to make this 3 millimeters wide. Now again, I'm going to add 0.15 millimeters to allow for that cleaning up process once it's been cast. So 3.15 millimeters. Press enter. Hold down shift, and I'm going to constrain to the right. And then you can see I'm sort of defining this arc. So I'm going to draw a fairly shallow arc for now. I'm also going to right click to rerun that command. 3.15, hold down shift, and now I'm going to draw more of a D shape. And the reason I'm doing this is because I want to show you what happens when we draw a shallow arc. If I turn my control points on, a shallow arc, or an arc which is less than 1/4 of a circle, can be defined by 3 control points. A more of a D-shaped arc, which is more than 1/4 of a circle, or 90 degrees, actually needs 5 control points to define the shape of this arc. So just be aware that sometimes if you are drawing an arc, you may go past the 90 degrees, and that's why it may look like this. There's nothing wrong with this, but just keep in mind, like when we draw a circle, there will be a crease here. This can actually be quite helpful if you're drawing a knife edge or something like this. It will have that crease or that point there. So I'm just going to undo, and I'm going to grab this, and I'm going to move it from the center there right to that point there. Now I just want a simple line. I'm going to go from there to there. So I know this is 3.15 millimeters long. And then I'm going to move that from there. That's going to snap to our finger rail there. Let's draw another line from here to here. And one more line from here to here. And obviously with our snaps on, this is making it quite easy for this all to align. Now I can select all of those and join. I can hit the button over here, which is to jigsaw puzzles. And now if I scroll up to our properties, you can see we've got a closed curve. So if we're going to be doing any sort of work or sweeping, we want to be doing that with closed curves. So from here, I can either do a sweep one rail using the finger rail or the outside rail, or if I wanted, I could do a sweep two. There's not much difference in this case. So I'll just do a sweep one. Sweep one, and let's ask for our shapes. This is the shape that we want. Right click. Now we've just got the one profile, so our curve seam doesn't matter. Doesn't matter where this is. I'm going to right click again, and we have a preview here. I'm just going to hit OK. So that's it. That is our half round ring. Now let's say I want to get rid of these sharp edges here. So there's two ways to do it. I want to fillet this edge. The command is fillet edge. Fillet edge. It's going to ask me for a radius. I'm going to use a radius of 0.5. And then I can select the two surfaces, or edge surfaces here. Right click and right click again. Now, history has broken, but you can see that we've rounded off this inside edge here. I can right click to rerun that command and do it on these two edges as well. And now you can see that I've got a bit more of a rounded profile there. So let's Control Z, Z, and we are now back to our original state. Now the other way of doing this would be to select our profile curve, and from here I can do a fillet corners. Fillet corners. And if I select my radius to 0.5 and press enter, then we've done pretty much the same thing, except we haven't broken history. So I can move this profile around and the ring is going to update. So for example, if we had a larger finger size, I can simply move this to the new finger rail and this is going to update like that. So two ways of doing it, of filleting these edges. You could argue that this is perhaps the better way because it does allow you to preserve history. We've got our band, and now let's say that we want to 3D print this. We're either going to print this ourselves or we're going to send this off to a casting house and they're going to print and cast it. So a 3D printer is only going to accept a couple of different type of file formats. When we save in Rhino, we're saving this surface, which is a NURBS surface. We're saving this as a 3DM file. This is a file which is native to Rhino. A 3D printer's software is not going to accept this. It's not going to recognize this. It's only going to recognize a mesh file. And a mesh file is going to be saved typically as an STL, which stands for stereolithography. So let's save this as an output or a production ready file. I'm going to come to File, Save As, and then all we need to do is come down here to where it says STL file. And I'm going to change this to output. This way I can see that it is our production ready file, and I'll press save. We're going to have a bit of a dialog box here, and you might see that it comes up like this, but you want to come across to the detailed controls. And then I'm going to set everything to 0. So everything is 0, and then the maximum edge length, I'm going to set this to about anywhere between 0.1 and 0.3. And this is going to give us quite a fine mesh, which is still going to be quite lightweight. So I press save, and you can see that we've now saved as output.stl. Let me grab our file. This is it here, the output file. And if I double click this, this is going to open up in Windows 3D Viewer. And it looks a bit dark here. If I press Control and 2, that's going to lighten up. And if I zoom on in here, you can actually see this surface gets broken up into these square patches. And this is that surface tessellation that the STL is creating, the mesh surface. Now, it always is a good idea to open up the STL file in an external viewer like this, just to make sure that nothing else has been sucked into the model. If you've got something in Rhino which has been hidden, when you save this as an STL, it will show up in the file itself. So I will close that, and I can also bring this into Rhino itself. I'm just going to import this in, and I'll just say always use these settings and press OK. OK. And now you can see that we've got our mesh here and then our NURBS surface. And although the mesh looks like it was squares, it's actually made up of these small triangles. It gets triangulated. And the STL is what a printer's software is going to need in order to print this accurately.